Okay, so at this point you should have seen the video on a 2x2 using row reduction or row echelon or Gauss Jordan. They're all called different things. It's the same idea. We can change rows if we want to. We can multiply or divide rows by numbers if we want to, or we can combine two rows together by multiplication and addition. So the object again is to get all the way down to this identity matrix, and you notice that this is a 3 by 3 because this has three variables. We need three equations. So all we need to do is put it in its augmented matrix. So I've used the coefficients here. Again, that little dotted line is to separate the variable section, the x's, the y's, and the z's from my equal to sign. So I'm looking for a lead 1. And I don't have a lead 1 here, but I do notice that I have a lead 1 here. So what I'm going to do is I'm going to take row 3 and exchange it for row 1. So you'll notice then I just rewrote the whole thing. The second row stays exactly where it is. The third row becomes what was row number 1, and the first row becomes what was row number 3. So now I have my lead 1 that I need. The object then is to get all the rest of these turned into zeros. So I'm going to take 1 times 2 and add it to negative 2 and put it back in row 2, which is going to give me that 0. So again, you'll see that I like to write this notation here so I can keep track of what I'm doing. These problems have a tendency to get really long and really calculating. So it's nice to have a reminder here of exactly what it is that you did to get from one to the next. So let's keep going then. That means I take 2 times first row, so 1 times 2 is 2, add it to 3 and get 5. Let's try that again. 2 times 1 is 2, plus negative 1 is 1. Put it back in row 2. And then the last one, 2 times 3 is 6. Add it to 2 and get 8. So that gives me my 0 there where I need it. And now I need to turn this row into a 0 right here. So I'm going to take 1 times negative 8, add it to 8, and put it back here to get this to be a 0. So 1 times negative 8 is negative 8, plus 8 is 8, which is 0. There it is. Let's do everything then. Negative 8 times 1 is negative 8, plus a negative 6 is negative 14. Negative 8 times 1 is negative 8, plus negative 2 is negative 10. Negative 8 times 3 is negative 24, plus 16 is negative 8. Okay, so now we're to the point where this part of our matrix is finished. And if we use the rules that we have, then there's no way those things are changing from what we've got. So now we need to go to our next lead 1, and our next lead 1 would be right there. So now I'm going to work on this 5. I want that to be a 1. So I'm going to take row 2 and I'm going to divide it by 5 and put it back in row 2. Notice 0 divided by 5 is 0, so this is not changing. Okay, so I do that there, and I take 5 divided by 5 and get 1. I take 1 divided by 5 and get 5, 1/5, sorry. Yeah, and I'm not going to be able to avoid these fractions. And I'm not going to want to turn them into approximated decimals. So you can this one because it's a nice little decimal, but don't expect that you'll be able to change your fractions into decimals and use them this way. So then I do that for each one. 1 divided by 5 is 1/5. 8 divided by 5 is 8/5. Okay, so now I'm on this column, and this is staying. Everything else needs to be turned into zeros. So I'm going to take this row times -1, add it to that row, and put it back in that row. Okay, so let's do that. And again, -1 times 0 is 0 plus 1 is 1, so none of this is changing. This 1's not going to change. The only thing that is going to change is the numbers here. So, sorry, -1 times 1 is -1 plus 1 is 0, and there it is. -1 times -5 is -1/5 plus 1 is +4/5. -1 times times 8/5 is -8/5 plus 3 is 7/5. So we've got our 0 here that we wanted. Next thing, we need to turn this into a 0. So I'm going to take 1 times 14, get 14, add it to 14, and get 0. I'm going to take 1/5 times 14 and get 14/5, add it to -10 and get -36/5. I'm going to take 8/5 times 14, add it to -8, and get 72/5. So now when it comes down to it, I've got these parts of my identity matrix fixed and finished. So now I just need to move on to my last one. And on that one, I need this number to be a 1. So what do I have to do to it? I need to multiply this row by the reciprocal, which is -536, and put it back in that row. So 0 times -536, again, this is done because there's nothing happening to either one of these. So then I'm left with -3/36 times -536 is 1, so I'm left with that. And then 72 times -536 is -2. And you'll notice then when I do that, I end up with z equals -2. Let's move on then. I need to take this and change this column into my zeros. So what do I have to do? I need to multiply this by -4/5 and add it to this to get 0. I need to take this times -4/5 and add it to this and get 3. Notice when you get that done, you now know that x is 3. Last one. I need to take and turn this into a 0. So I'm going to take 1 times -1/5, add it to 1/5, and get 0. I'm going to take -2 times -1/5, add it to 8/5, and get 2. And so finally I see that y is equal to 2. So my final answer then is my nice little triple of 3, 2, -2. And again, this is called row reduction. This is called row echelon. This is called Gauss elimination. This is called Gauss-Jordan elimination. And there are lots of videos out there that show you how to do these again and walk you through the examples. And we will fine-tune this a little bit as we go on, because there are some, remember, there are 7 different ways that we can come up with answers here. This one gives me a nice little triple, and that's what we like, but we have to look at some other possibilities as well. So your homework is going to go from doing 2x2s to doing 3x3s or 4x4s or whatever size matrix it is. It's all the same rules. Just keep working. We'll make it through this.